Dave Whiteley. I'm Technical Director of Envisage UK Limited, and I'd like to take this opportunity to go through the new features available in the latest version of Inventor 2015. Okay, we'll start by producing a sketch in Inventor. I'm just going to hover over the plane here to actually start a sketch, and Autodesk have now added the work plane name in the corner of the work planes. So in this instance I've actually changed the XY work plane to sketch, as you can see, and as I hover over this, the name appears in the corner of the work plane. This is really useful when you've got planes very close to each other, parallel planes especially. Right, let's have a look at some sketching. I'll do something simple first. We'll just do a bit of a U shape, and as you can see, when I start sketching, the constraints that are being inferred, in this case the horizontal and perpendicular constraints, are showing on the sketch immediately, and you will always see on the last but one geometry it still shows the constraints on the sketch, so you can actually tell that you've done it right. Now what I'm going to do now is I'm just going to go up to in line with this horizontal line here, and you'll notice normally we're expecting to see a dotted line shoot across from the previous line along here, but in this case it's gone black. Now whenever you see a black line, lo and behold, you're now going to have extra constraints applied. So now that I just produced this sketch, straight away I've got a collinear constraint added between these two lines. So when you're sketching, look out for this bold black line shooting across from one other piece of geometry, and you're going to get a lot more intuitive and accurate sketches straight away, as opposed to actually having to add these constraints afterwards. Let's add a few dimensions to this, and what we'll do here is we'll have a look at some new tools that are available to us. Let's just highlight some geometry. If I highlight some geometry in a sketch, again you see the constraints appear on the geometry. You don't have to show constraints anymore if you don't want to. And also if I highlight and right click on one of these, I can actually delete these constraints from the highlighted glyphs that we see on the sketch. So really a useful tool in that you can just now select geometry and you can see the constraints straight away. Right, new functions is the relax mode in Inventor. There are times when you may want to move some geometry, but you can't because of the constraints that are added to the geometry, and this causes us problems when we've got so many complex constraints. Perhaps it was modelled by somebody else and we want to modify all this, so we've got to go and find the constraints that we need to delete. So if I go down to the bottom of Inventor here and put on relax mode, which is F11 on the keyboard by the way, I can literally move my geometry, and as I move my geometry you'll notice it's showing the constraints highlighted in a magenta box to actually show the ones that are going to be suppressed, if you like, or deleted when we change the geometry. So if I now let go, that now updates the sketch and the constraints are removed to enable me to actually go ahead and change this sketch. If I take off relax mode, then we're back to square one again. So fantastic tool. It allows you to override the constraints that are on your sketch already and intelligently remove the constraints that are not required. Now here I've I need to add a constraint to my geometry, and we get this quite a lot in Inventor, whereby we look at our sketch and we go, right, okay, I'm going to add a horizontal constraint to this, not really looking at the coordinate system in the bottom left hand corner. So if I go to horizontal and move across to the line and start to add a horizontal constraint, can you see that it actually shows a yellow dotted line to show you actually which way it thinks or it knows the horizontal constraint is. So in this case obviously I need to go to the other constraint, which is vertical, and then the yellow preview line shoots off in the correct direction, and I can select that line and correct it accordingly. What I would like Autodesk to do on this is to enable us to, if I was in the middle of this and said, okay, I want a horizontal constraint, no, that's not what I want. I'd like to be able to press perhaps the Alt key so that it would automatically switch to the other type of constraint and allow me to constrain it straight away, as opposed to going up here and then selecting the correct one afterwards. One other thing that they've done is, in this release, is if I go to offset. Now the offset command, first of all, you'll notice I can now type in the offset value immediately on the offset command. That's the first thing. And secondly, with offset, what it will do is it will now calculate, it will allow you to produce offsets which in the past were broken because they weren't able to create the offsets. In this case, it's correctly given me the offset required. As this starts to waste down to nothing, it's producing the correct offset that I require in this sketch. So a few tools that have been improved on sketching. Also, what's happened in the settings is if we go to the bottom right of the dimension button, you'll see constraint settings, and in here everything to do with the constraint settings are now in one dialog box. So for instance, information about the relax mode, the inference, which used to be separate buttons, whether you want your constraints to come off parallel and vertical, horizontal and vertical, parallel and perpendicular or horizontal and vertical, and general settings like do you want to display constraints on sketching, on creation, and so on. The over constrained dimension, do you want to warn of over constrained or apply driven dimensions? It's all on this one dialog box. Okay, let's have a look at modelling now. I'm going to go straight into an assembly model here, and we're going to look at new functionality that we have available to us in this release. So I'm just going to go to this. This is part of a car seat. I'm going to finish off the rear cushion of this car seat. The tool I'm going to show you is fantastic for organic shapes, which can replicate themselves to any sketches that you've created as well. So it's not as though this is just purely freeform stuff. So let's just get into this this model, and in the 3D model ribbon you will see that we have available to us freeform tools. These are the T-splines tools that Autodesk acquired some time ago. It's been in Fusion 360 for a long time, and a certain amount are in Inventor. Not all, but I would like to see in Autodesk certainly put more tools in Inventor that have come in, that have been in Fusion 360 for a while. So let's add a box to a point on the corner here, on the center of this work plane. And we're going to start looking at the sizes here. So for instance, the length, I'm going to select this 375 dimension here. It's automatically putting the D value into this dimension for us so that the length is selected correctly. The width, the same thing, this dimension up here. And the height will be 100 millimeters, and that will be symmetrical. We'll just change the number of faces as well on this. Okay, so we've got 4x2 patches. And this is creating us a box. It's not a square box as we'd expect to create an Inventor. This is freeform modeling, so these are surface patches creating a more organic shape. Okay, so let's have a look at this. Let's have a look at this on the left hand side. Now I'm going to start modifying this, so let's edit the form, select the solid, and you can see the grips here will allow us to actually move the solid. I'm just going to move this by 10 degrees just to rotate it over. Let's then go and have a look at this on an isometric view, and what I'm going to do now is I'm going to use a fantastic tool called Match Edge. What this enables me to do is select the freeform model edges. I've just double clicked on one edge and it's automatically found the loop that goes all the way around, and I'm going to match this to the sketch underneath. We'll give it a tolerance, click on OK, and what that's now done is that's matched those edges on the freeform model to the sketch in my design. Right, we'll add symmetry to this, so let's just go to symmetry, select two opposing patches, click on OK. We've now got symmetry, which basically means now that if I start moving this around, let's select, let's divide these patches up here, add a few more patches, so we'll subdivide this. Okay. Gives us a bit more control in this area later on. And we'll start adjusting these. So let's perhaps take these two patches here. Let's look at this front on and edit these patches. And you can see that I can now pull these patches around. I can pull these, I can give these specific values. I can move vertically and horizontally by clicking on this face here. I can rotate, to twist, and so on and so forth. And as I'm changing this, obviously because I've got symmetry on, it's changing the other side as well. Let's take these patches, and in this case we're going to edit this. We're going to use the extrude option. I'm just going to push this in. Now the extrude option will actually give us, it will do the freeform modeling of extrude as we know in Inventor, whereby instead it will give us a much coarser or larger draft, if you like, around the edges here to give us a extrusion, so we can actually push these faces in but still give us tangential patches all the way around the edges here to give us a smooth link, if you like, between these patches as they transverse across to this area here in the center. Right, let's have a look at the top here. Again, we'll subdivide some patches. So let's take this one here and subdivide. Okay. Good. And we'll just take these two and we'll edit this form. We'll just push this up. And we can do this a number of times, and each time we do this, it's actually going to create a set of patches each time. So if you look at this vertically, we've got two sets of patches vertical on this. What I'm going to do now is this is a fantastic tool. This is bridge. This enables me to bridge across between patches, so I can take these two patches here and bridge across to these two patches on this side. And it'll take a while, but then produce us this fantastic freeform surface model of our car seat. And there you are, freeform modeling. It's a solid now, so you can do the usual things to it: cut, split, shell, you name it, we can do to this freeform model. Another set of tools, direct editing. Let's go ahead and have a look at this simple model. Now this model has come through from a third-party model, so we've actually got a dumb solid here. Dumb in the fact that there are no features, but not dumb in the fact that we can actually change this in Inventor. So let's have a look at the direct modeling tools that we have available to us. Direct modeling enables us to literally take part of our model, whether it's an Inventor model with features in or a dumb model that's come through from an imported third-party CAD file, and we can work on this model. So for instance, I could select perhaps this lever, locate the axis to the center of this cylinder here, and then I could say, well, okay, well, let's rotate this. Let's just relocate this again. That's better. And as you can see, I can now change the model by this direct editing tool. Let's put an angle in here. So let's actually say switch equals 20. So what I'm doing here is I'm changing this angle to 20 degrees, but I'm also giving it a parameter name of which is called switch. This is a useful tool in Inventor. If ever you need to add a named parameter to your sketch or your model, you just type in the name of the parameter equals, then the value, and it produces that parameter for you. Okay, so we've now edited or directly edited this model. And if I go up to my parameters, in here I can change my angle to say -20, 45, and it adjusts the model, as you can see. Let's take it a step further. Let's go into iLogic, and we'll put the browser on. We'll create a form, and we'll add the switch parameter to the form. We'll make this, instead of a text box, we'll make it a slider. We'll adjust the slider properties, perhaps go to a maximum value of 360 with 10-degree increments. Okay, now if I run this form, you've got an iLogic driven model that came from a third-party CAD file that we're actually directly driving within Inventor. Let's open something else up and have a look at the direct editing. Let's have a look at this casting. This is an Inventor model, so it's got features in it. However, sometimes it takes a while to find the relevant features on your model to alter. It could have been created by somebody else. So what you can do here is go to direct editing. Say I want to change the size of this diameter of this cutout here. I could go to size, select the cylinder. Yes, I can adjust the size here, but actually I can change the size by inputting an offset, a diameter or a radius. So I could go to diameter and say, right, well, I want the diameter to be 200 millimeters, and we've now adjusted that model to give this cylinder a 200 millimeter diameter. Directly edited. It's a feature in the browser, as you can see at the bottom left here, but I didn't have to worry about trying to find the feature that actually produced that. Let's try something else. Let's take this edge here. Now this edge I want to align with this face. The problem I have initially is that that edge is not parallel to that face, so I can't just extrude it to that. What I need to do is rotate first, so I can say, right, well, let's select this face. We'll snap parallel to that one. So let's change this face so it's parallel to this face. We'll then go to move, and we'll select this face, and we'll move it to this one here. Snap to this. Whoops, do that again. And there you go. So we're using direct editing to turn a face around to align it with another one, and then extend it to that particular face. And of course, any draft angles are honoured, any fillets would be honoured. Fantastic tool. It enables you, this would be great for things like castings and forgings, where you've got complex fillets and so on. You need to adjust this model. anything really, anything that's come in from a third party. You know, we've been able to edit third party models in the past, but this has taken it a whole step further in that we can adjust just about anything in a third party model that's been imported. So that's the direct editing software. Let's have a look at a few new features. Let's go to the twisted option in sweep. So let's take simple sketch. What we've got here is just a number of sketches, and I want to do a twisted bundle of wires. So I'm going to use the sweep command, select the profile, select the path. Now what is new is the fact that we can actually give it a twist. So I could say, well, this is 360 times 5, click on OK, and we've got our twisted wire as part of the sweep command. If I share the sketch, then we can go to the sweep again, select the next first profile. Let's make this a new solid, so we're working with multi-body model now. Put the twist in, 360 times 5. I could have actually set this as a variable, and there we are, there's our twisted wires. So if you need to actually twist anything along a profile, you can now do that in Inventor 2015. Okay, let's have a look at assemblies. Okay, you'll notice this assembly is opening in Express mode. For those of you who haven't heard of Express mode, it's been in Inventor for a while. It enables you to open up a large assembly extremely quickly because the model itself is held in the assembly file. The drawback in the past was the fact that we couldn't really do much. Well, we couldn't edit in place, we couldn't create components in place, we couldn't pattern components, we couldn't copy mirror, we couldn't assemble, we couldn't use point cloud commands and so on. In 2015 we've now got the ability to do all this. So for those of you who are creating relatively large assemblies, to be honest, I would stay in Express mode most of the time now. Hard disk space is cheap, so we can put up with the fact that the assembly files are larger, but the actual the benefits of being able to open these extremely quickly it far outweighs that. Right, let's take this chassis here. Okay, and we're going to start looking at some of the assembly tools, but before we do that, we've got a sheet metal part here to have a look at. Let's edit the sheet metal part, so we'll just select the pre-selection to part priority, and we'll edit this. The punch tool. If we go to the punch tool, take these reinforcement plates, and we'll just deselect these. We don't want these on the top here. There we go. New function in the punch tool is the fact that we can now punch across bends, so that these particular relief or strengthening punch tools on this sheet metal part will be added to the sheet metal component, but also because we've got the ability to transfer it across the bend, you can see that it does all the work for us. Okay, we'll close that down, we don't really need to save it. So let's have a look at the assembly tools. You've probably noticed that we've now got, not only have we got constraining assemblies, but we've also got joint. The joint tools are fantastic because whereas in the past we may have created an assembly constraint using 3 constraints, we can now assemble 2 parts together using 1 joint because the joints are more engineering based. So we've got things like rigid joints, which would replace perhaps 3 make constraints in the past. We've got rotational slider and so on. What I'm going to do here is I'm going to connect up this sheet metal part to the rest of the body. So we'll just take, let's just go to this part here, this point here, getting a bit closer. Okay, what I'm going to do now is right click and say let's offset the origin. And the idea of offsetting the origin is that we can actually take a point and then offset it by a particular value. So if you know that your connection point is offset from a point that we can actually connect to on the model, you can offset it now, which is fantastic, because you know it could be that I actually want to weld this 25 millimeters away from that edge, and I haven't got a point here to select, but I can now use the offset command. And let's connect this to the front of this bar here. Let's align it. And away we go. So we've now assembled it together. Another useful option in joint, I've got this bar to add to this hole here. And sometimes you want to center things, and this has always been a problem because you've had to add a mirror plane to the component. So now if we go to joint, before we actually select anything, we can right click and say between 2 faces. So I can now say, well, actually my joint is between the 2 faces of this bar. Let's just take the axis as well, and that will actually give us a joint contact point at dead center of that bar. And I can do exactly the same now by saying between 2 faces of these plates. Step the center, and that will put the bar together and add a rotation joint, because that's what it's worked out from the geometry I've selected, but it will center the bar, so that any gap I've got or play that I've got will be the same on both sides. Now here's a fantastic tool in sheet metal. We've got the bar going through, interfering at the moment with this sheet metal component, so I need to cut out the sheet metal component with this bar. Now the problem we've got is the sheet metal face or flange is at an angle. So if we cut this out at the moment, in 2014 this would have cut it out and given us a circle at both sides, well, an ellipse at both sides, but offset from each other, and not really giving us the correct cutout. So when we create the flat pattern, we're not getting the correct cutout that we require to allow us to put this shaft through the hole. And this has been a problem with anything where you've got cylinders interfering with other cylinders, and at the transition you want to create perhaps a paper template for the welders or the fabricators to wrap around a steel tube to cut that out. And in the past, if you look at both sides of a thick Inventor flat pattern, you'll notice the profiles are different both sides. So let's have a look at this. Let's take the sheet metal part and edit it in place. Let's sketch on the center plane of this sheet metal part. Let's put this view back to where it was. Let's project the bar. Let's just go to transparency and turn it off so we can actually see the bar. There it is. Project this so we get a circle on the sketch on this sheet metal part, and then we're going to go to cut. We're going to cut this profile in both directions all the way through, but most importantly we're going to cut normal. And what this will do is this will cut through the sheet metal part on both sides, but if we then go to flat pattern this, what we're going to get is the correct profile for this flange, so when this actually gets folded up, the bar fits correctly through this profile here. It's a fantastic tool. We've been waiting for this for a long time in sheet metal, so enjoy it and use it. Stop there. There's probably more. I might do some more what's new videos later, but that's a good taster of what's new in Inventor. We've got additions to the frame generator, for instance. I might do that as a separate video later on. Keep an eye on our YouTube channel. The information you need is here, so if you just look at Envisage UK Ltd, videos are posted to that one regularly. If you want to contact me, my email address is on this page, and thank you very much for watching.